Typey. Hello, everybody. Welcome back to another hardware stream. Look at this. We got another person to show up too. Mike. Hey, Mike, welcome back. You were away last week, or you were getting ready to go away last week.
I was promised rat nesting, so I'm excited.
Okay, so we're going to have a little bit more fundamental work here today. So just to get everybody ready, you might not see as much layout as you want, but you'll see some other planning that I've been thinking about for a couple days, some of which comes from the stream I was on with Dan and John and Sam on Friday.
Yeah.
Dan, do you want to sell the Friday stream?
Yeah, well, the Friday stream is all things to all people, but this past week we've been doing kind of a series, I guess you could say, on building a product kind of from scratch on Goliath. And so that right now is looking like the first episode was brainstorming. The second one was doing some planning around the design of the hardware and what components we want to use, which I found really helpful. I think like sourcing components is probably something I have the least amount of experience in the hardware realm. And so it's like interesting to go through the rationale of why you would choose one component or the other. Because there's so many dimensions, right? The footprint, the cost, the availability, the software support. So I don't know. I enjoyed that quite a bit. So if folks are interested, check that replay out.
Yeah, and we are taking some swings as well, because so that's Sloshy McWashy, the what is it, a washing machine detector thing. So it's not like we don't have hard requirements. That's always a tough thing. I think that's kind of what we're dealing with here. But one thing that I was excited about for the Dram board, which we're talking about here, is that it could actually lean on some of those needs of the Sloshy McWashy project, because ultimately, we're basically making like a module breakout for a lot of the functionality that's on the elixir. The elixir being I don't have one here. There's one in here somewhere. So the elixir having a 9160, having a ESP32C3, basically a bunch of sensors, things like that. That is kind of where we're starting from for the Dram board. But one thing that is also in my mind, basically making a castellated edge kind of breakout module type thing that could be reused a bunch, is that you're basically creating a hardware, bad term, but hardware abstraction layer, really like an abstraction in that it's a bunch of connectors around the edge of a little board that you're doing. And in doing so, you could start to say, well, maybe the specific parts we're using, as long as the functionality stays the same, as long as the input output stays the same, as long as the power stays the same, then you could start to swap in different parts. And some of the stuff that Dan was talking about with like choosing stuff and sourcing whatever, yes, the software piece still matters quite a bit. But if you lean on something like Zephyr, you can start to maybe swap stuff out, or you could retarget just using the Goliath SDK for different firmware for different parts and still have the same ultimate like cloud side capabilities with a different set of firmware. But ultimately then, having a module allows you to abstract away some of the specific routing differences that might be like, oh, well, if I have GPIO going to, 0.29 on the NRF 9160 and 0.24 on the NRF 52840 that's talking to a BG95, same, right? You just do a overlay file in Zephyr, and that allows you to retarget that sort of stuff. But ultimately, it's the format of the castellated edges that will become the new thing that gets carried from design to design. Does that make sense? Yes. What about you, audience? We have 6 people watching. Oh my gosh, we have 6 people watching. So last stream, I think on Friday, actually, I told John after the fact, I was like, I forgot people were watching because we were just joking around and like I was just making generated art on Midjourney as we went along, just claymation washing machines running down the street. So let's do more of that.
Yeah, I agree.
Okay.
I think that the purpose of a live stream is to forget that people are watching.
So. To feel alive.
Yeah. Right.
Let's do a little bit of news first. This is going to go live. Let's do a little preview. This is like a live live premiere sort of thing. We are going to be launching in about an hour. All of our existing hardware is going open source. So that's kind of exciting. This is stuff that Mike and I and Chris Wilson and Marco have all been working on in and among the other Goliath team members, but we've been working on this stuff for a long time. We've had multiple revs, and we're really excited that we're going to actually be pushing this stuff live very soon, like within an hour. And that's really exciting. Another thing.
Yeah, nice job getting that across the finish line, Chris. I know it was on our backlogs for a long time.
It was there.
I mean, there's just so much parts of an open source repo of that scale. So it's nice to see it.
You know what it came down to is when you work in private, like non-stream, it's really easy to kind of leave detritus everywhere, which I do. People will see my, I leave like images in the margins, and you don't have the best part number. It was not a production level design, so it was like I could be a little bit messy with it. And then when you release it open source, you should not be messy.
Did you put pin numbers on the silk screen? Because that's my favorite.
Oh, yes, there are. Yes, Mike does not like when I didn't put silk screen. I usually don't put reference designators on boards. Like so,
right,
you see the one on the right here, the Astentis. That's the front panel. That thing's like this beautiful matte black solder mask, and it's like I don't want anything on there. No white silk screen, please. Like I just want to leave that.
But on the bottom, you won't see it. It's only when you're poking around trying to figure out where the signals are.
Yeah, I know. You'd figure it out, Mike. Come on. So yeah, that's really exciting though, and now people can go and take it and modify it and kind of do what we're doing here, right? We started from the Elixir board last time. Now those files will be available for people, and you could, kind of this stream kind of represents what we expect people to do. I think further down we kind of talk about the fact that this isn't production ready; it's the 80% done. And this is kind of some of what we're doing with the Dram board is kind of the expectation that I've always had that people would do with these files, which is take it and extend it or shrink it, or like make it more compact, make it more something you would put onto a part, maybe put into a module like we're doing. So we're living our own truth here, guys. All right. What was the other thing I was going to mention? Oops, that's the wrong window. I was going to show as well training sign up. This is another thing happening today. Too late for you to sign up for this one, but we do have another training coming up in September of 2024. I'm only mentioning this because right after the stream, I'll be going to training. We train people on Zephyr, and we use development kits from Nordic. So, and a bunch of code spaces and stuff like that. You can get started on Goliath. You can learn how to do Zephyr. You can learn how to build up, easy Zephyr programs using infrastructure we've already kind of set up for you. And I think that's ultimately really, really useful. So next one's coming up on September 11th, 2024. You can sign up here. Drop this in the chat. Where did I do that? It's just the upcoming training 2024. And yeah, we'd love to see you there. All right, I guess I have to open KiCad now, huh?
Did you make those repos public?
Oh yeah, we're gonna do that live, huh? Yeah. So these are the not yet live. Yeah, this still has a little lock here. All right, let's go to the danger zone. What do you guys think?
Danger zone, highway to the danger zone. All right, who's saying highway to the danger zone?
Yeah. Mm-hmm.
Not me.
What? I have to sing it?
No, who sang it? What was the band?
Oh,
there?
Kenny Loggins. Come on, man.
Really?
Oh yeah. You don't know that? How do you not know that?
I know it now.
Yeah.
That's why I came to the live stream. I needed to know.
When I was in, I like that we're doing the GitHub two-factor auth here.
Nobody has it on their phones. Actually, this never works for me too, so I'm gonna have to use my password anyways.
Oh,
yeah, you
go
might
off screen with that.
I'm just gonna pull you down here for a little bit.
I'm not typing. Guys, I use a password manager. You're not gonna see my password. Don't worry about me. Use a password manager, folks.
Yeah, but what if they're analyzing your keystroke sounds?
I might have
They can
audio
still hear
stop.
that though. Yeah, we'll have to put you on mute. We can bring you back now.
Okay. I'm gonna do it again. So just so you know,
You shouldn't have to
so I have to do
re-authenticate though.
elixir now.
The
Back to the danger zone.
when I was in college, we had like a college radio station thing, and myself and a couple of my friends were on the. We had a sports talk show, and we were on at like 1
Really?
a.m. because like
Dan
very,
Mangum was on a sports talk show.
yeah. Very, very small following. And we were on at like 1 a.m. because like it was very low quality content. And but the name of the show was The Banter Zone, and we remixed The Danger Zone and made our own version. So I have to pull it.
Very happy about that. Yeah. All
You
right,
now
both of these are
owe,
now
royalties
they are now
to Kenny Loggins.
right. We that's another reason we're on at 1 a.m. They didn't want any lawsuits.
Yeah, I remember I went on the Northwestern. My buddy had a show on the Northwestern University radio program, and I was so nervous to like talk into that microphone. It's amazing how different it is when you're like talking to a microphone that actually gets broadcast versus like, basically talking to yourself for a podcast. It's
yeah.
Nice. Podcasting, huh guys?
So those are both live.
Live.
And everyone should go star those. I am the only star on both of them, I noticed. So I always star our private repository, so they all have 1 star.
What does starring do? It just lets you follow it. Is that right?
Actually, watching is separate. So starring is just like, I like this.
Okay. I also like this. Should I be starring your private repository so that like you get? It's like one of those things that doesn't really have. It's like good feels basically.
Yeah, I don't think. Well, I mean, it impacts like what's on like the trending page on GitHub and that sort of thing. But obviously, if it's private, it's not going to be on there. So private stars really just don't mean too much.
Got it. Okay.
At least that's my understanding of it, I should say.
Okay. All right. So I'm going to pull up the design here. Let me get this into the right screen. So one thing I want to do today is to actually think about some of the parts. Ultimately, I'm thinking about the envelope of different parts here, right? Because one thing that we had talked about last time, I basically put in the NRF 9151 and the ESP32C3 mini in there, just to kind of get like kind of rough shape. Obviously, I didn't do any traces or anything like that, and that will continue here today. But one thing that ultimately means is you can't go smaller than the things that you're putting onto your board. And we didn't even put down other devices on there. So things like MFF2 eSIM or a ATEC 608B chip. What's that called? Security chip, HSM. So that's the kind of thing that I'd like to get to today, get to the outside maximum there. And then I think it's about like things like we'll know how many max IOs we need. I think we need to make sure then the number of IOs that are available on the module it's like a least common denominator kind of problem, right? Because if I want to put a part on in 3 years into this new form factor, the Dram form factor, and it can't service all the IOs that are on the castellated edge, well, then that part just won't work. And I'm not saying that we should like optimize for a 8-pin 10-cent micro or something like that. But I think we should be reductive to the minimum that are available here. And then ultimately that'll serve as the hard requirement for future parts, right? So just thinking about so basically I think we should key off the elixir and say like, okay, we have, on the 9160, we have, I think, probably 20 or 30 IO total. Does that sound right, Mike? Some of them are internal to the board. Some of them will stay internal. So like things like the RXTX line going from the 9160 to the ESP32C3, the 4 lines that are dedicated there, because there's a reset and an interrupt as well, those are going to stay internal to the board, right? So those are IOs that are available in the 9160, but are not going to be available external to the board. So it's really about like probably the click headers, the quick headers or the stemma headers, and then additional, kind of peripheral type stuff there as well. Does that make sense? This is just I'm just thinking out loud, really. So feel free to tell me I'm not making any sense.
When you say least common denominator, what are you looking at only the chips that you're laying down now, or are you also thinking about future?
Yeah, thinking about future, right? So like, I don't think we should be like, oh, well, we have to chop out 4 of these. I think it's really just about like having a good definition there. So like thinking like, all right, we're going to have 16 total available GPIOs, and that then will define future things. So then so then say 2 years down the road, Nordic or NXP or somebody else makes this like really amazing part, but it's only got 15 IOs, it would disqualify that part. That's what I'm really saying, which is like tough, but a realistic kind of hardware, really a module based approach.
Okay, so then you say, all right, 16 IOs, but then the castellated edges don't have all of those. So it would be a smaller number?
No. It would be that.
Okay, so you're saying the internal pins are not counted in that. So you'd have like an 18.
That's right. Yes. Yeah. So you probably have more pins available. That's
well, you'd have the 16 plus the power and ground. Is there anything else that comes out of the module?
Yes, I think there would be some optionality, I think. But it'd have to be like non-critical optionality. So like things I was thinking about was like the I know I'm like going back on what I just said, right? But like thinking about, say you put down, let's just talk about 2 different use cases. So let's talk about that 9151 talking to an ESP32C3. And then let's talk about a NRF52840 or whatever the next chip of that would be, and a BG77, which is a smaller version of the BG95. That's one that I've like talked about, wanted to build before, but I think that ultimately that BG77 is going to define the outer perimeters of the module itself. The NRF52840 has D plus D minus for doing USB 2.0. So potentially we could put a optional USB 2.0 on there, but that doesn't actually exist. First off, it's not a good fit because of the castellated edge, like that basically is like a non-impedance controlled connection between 2 parts of the board, like the module you're on and the sub module. But I think it would probably handle it, but I don't want to put a USB connector on this module. That's what I'm really saying. So like if you wanted to have USB comms in the future, you could, but I don't know if we want to make that a requirement, So I expect that we're going to have a serial input to this thing. And then the serial input will be the main way that we talk to things like the main processing module. So either NRF 9151 or NRF52840 or ESP32C3, like we talked about on the Sloshie McWashie as the main processing element. All of those is like, so the lowest common denominator in that case is not USB 2.0. It's actually RxTX on a UART, right? So what that ends up playing out as.
What was the reasoning on the Elixir, the 9160 we use as the main application processor, right? And then the ESP32 is just for Wi-Fi.
Yes, that's right.
And was that mostly because we have the ESP AT driver and Zephyr support for Nordic and that sort of thing, or was there something fundamental to those parts that govern that decision?
That came up from Mike and I went to Embedded Open Source Summit in Prague, and Czech does not have LTE-M coverage. And so we were at a conference with buttoned up reference designs, and we're like, wouldn't it be great if we could switch over to Wi-Fi right now? Because everything is Wi-Fi at the conference. And we have on our follow-along hardware, we have the NRF52840 using ESP AT. And the other thing I knew is that the 9160, knowing from the previous Aludel Mini design, I knew that we were GPIO limited. We already were. And so even switching to like we were looking at maybe like the NRF 7002, but even the SPI based thing, if it was just SPI, we weren't sure if we were going to be able to have SPI on there, like a secondary SPI channel, because you wouldn't be able to have another SPI interface. If you wanted to use Wi-Fi, putting it on the same SPI interface as the microbus and the memory and the Wi-Fi, that would be very, very tough to actually, like take control of that SPI network. I'm not sure I don't even know if that would work. I don't know if you know, Mike.
Dan, were you asking about why we didn't use a different processor to run the show and then use the cell modem as an AT?
Oh,
yeah, kind of like
I see.
You could invert sort of and get the same thing, but I know we have the ESP AT drive already. So yeah, that's more my question here.
Yeah, I think we started the reference designs with the thingy. No, not the thingy. The Circuit Dojo Feather 9160. And so I think just kind of inheriting that choice into this is how we decided to go with the 9160.
Also just cellular first, right? I mean, like most of the time when you show up somewhere, you don't want to put in a Wi-Fi network, right? So like just thinking about our use case is going to conferences, showing it at a, customer site, things like that. Like you don't want to have to, unless you already have like the Bluetooth, add a Wi-Fi access point, credentials, that sort of thing. Like it's just, that was not a mode we wanted to operate in. Mm-hmm. But in theory, no, actually you couldn't, never mind. I was gonna say you could invert it and say, you could have the ESP32 C3 in charge and have that control, like the connection between the ESP32 C3 and the NRF 9160 is reversible, right? You could put AT firmware on the 9160. You could run the ESP32 as the main processor, but all the IO is hooked up to the 9160. So you would have to have, GPIO expander style communication or expander logic in there, which is probably not likely,
Well, also like to your point, if I mean, I don't know what the power impact of it is, but if you're like primarily using cellular, if you had it inverted, then you'd always have to be using both chips, right? Whereas if you're just using cellular with how you have it, if that's the primary use case, you can just be using the 9160 and not the ESP32.
Yeah.
So
yeah, I mean, and if I'm being completely honest, the 9160 is a fantastic component chip, and it's got dual core M33 Cortex M33s, and they're like, you'd be paying a lot for just using it as an AT modem. Like some people do it. It would be not a big waste of money. It's not like if you're high enough volume, it probably would be a wash, but like, it would not be my first choice as just an AT modem, right? It's not like that.
Oh, sorry. Also, this arrangement, I think you can still use the Bluetooth on the ESP over the AT commands, right?
That's right. Yep.
Yeah. So you get like two protocols for the price of one chip on this one.
Good point.
I mean, I think that's
we weren't thinking about any of that stuff when we started it, though.
Yeah.
Oh, I think we were. I mean, I think the first thing that we looked at was, you need to do it for the Wi-Fi option because of our experience at that conference.
Yes.
I mean, would that have worked well there? I don't know. How was the Wi-Fi there? Who knows?
Yeah,
right?
we have shown
bad at conferences, but
I mean, Chris Wilson did some experimentation with it where he got it, so basically it's using the AT command set, it's tied into Zephyr, it's running as a modem like it does with NRF 52840, talking to ESP AT, and all you have to do is switch off the cellular to like switch it into Wi-Fi mode, which is pretty cool. So like that could be a jumper, that could be a quick reflash, it could be I'm not sure if it could be a setting on Goliath. Maybe that'd be interesting, but So I think, but that architectural decision in both directions is interesting. I think at the end of the day, what we're talking about here though is putting both, right? We're talking about both. We were talking about both on the Sloshing McWashy as well, where now the ESP32C3 is in charge, and the BG97 is just an AT modem, and using BG97 is just a smaller version. It's the same silicon as the BG95. I think it's the 9205, whatever the Qualcomm chipset is, and Yeah. So we can use like the stuff Mike's been doing on the rack 5010 as well with the what's it called, modem subsystem. Is that right, Mike?
Yeah,
Yeah.
modem library, I think I call it.
Okay. Yeah. So short term, here's what I want to do. I want to put a BG97 footprint schematic symbol on here just to size it out, right? So that's going to ultimately, we're still floor planning. We're still figuring this stuff out. If we look here, I was using this as a guide before, right? So this is the ESP32C3. I had talked about potentially taking this just down to just the chip and crystal, and maybe not using a pre-configured module. We might actually use the UFL version, the mini C4 or whatever it was, that has a antenna as well. And then, but basically trying to get this smaller, right? But even though we're trying to get this smaller, we're using this kind of ad hoc, kind of figuring it out sort of thing with the microbus as the outside envelope. It's not a requirement, right? It's just, we're just figuring this stuff out now. So this is what I do at the I'm super choppy right now. Am I super choppy?
No, look fine to me.
Okay. I think it was as I was scrolling in and out. My computer's struggling with two monitors. Of course, 2024, two monitors.
I feel claustrophobic looking at this, Chris.
This?
Yeah.
Up and now.
Yeah. But what's your general feel? So you say you just try to get a feel of it. Like looking at that, do you look at that and go, "Ooh, that's going to be a lot of routing," or is it okay?
Well, the main thing that would go between this stuff, this is not like, remember, this is still hooked up to all the crap from the elixir, right? So a lot of this stuff is going to go away.
Why.
Yeah, that's why. Here, I can fix this. Okay, so if you go into visibility, I can fix it, Mike. I can fix it.
You don't need to fix it. I was just looking for your gut on, if you look at this, do you get heartburn, or you're always cool as a cucumber.
Oh yeah. I think the thing is, the scale is ultimately driven by a couple things, right? So it's driven by what type of board you're going to do. I usually get heartburn when it's like, oh, you're so tight in these spaces that you're gonna have to switch to an HDI board. Like in my mind, that's like, it snaps into like expensive territory, right? So like you can get down to like 3 mil space trace and these micro vias and super tiny stuff. Like you could do it, but like I'm not making an Apple board anytime soon, and I don't need to be paying Apple kind of prices. You know what I'm saying? Like, so like that's usually the switch over. So it's like, am I switching to 6 layers? Actually, okay too, I think. But it's really the vias. You start, when you have stuff that's this small, anyways, right? So you look at like these things aren't being used, but even these pins being so close together, you just start to really get space constrained, and it gets kind of messy. So when you get to HDI processing or getting past 6 layers, like that's when I start to get kind of antsy. So I think we'll probably get away with 4 layers, depending. I would probably start at 4 layers, or maybe have a 6th layer in there in case you need it. But that would give us, you definitely need a ground layer underneath the top layer here for RF routing, right? So for your 50 ohm controlled impedance lines, and then you want a power layer probably just to deliver power to this thing, and then probably fine otherwise. Okay, so what I was going to do, I was going to drop in a BG97, right? So BG77, making up new parts here. And I had that available on SnapEDA here. So SnapEDA, if you don't know, is a footprint service. Basically, you can lean on their expertise and their creation of different symbols, and they also have 3D models in here, which is super nice. So I'm going to go into download footprint, select KiCad version 6 layer. It's going to make a so open the folder here. Okay.
Man, this is worth the whole live stream right here. I've never used this tool for footprints. Yeah.
Oh, it's great. So then I'm going to open a new folder down here. Open up the design folder. Okay, so this is the Dram repository, people may remember last time that I usually do input and output like this. So I'm going to go to input, and then this is Helmet's library. So Helmet has this is actually a submodule that we're using. So I'm not going to mess with this, but we're going to kind of mirror the same format here. And you see now we actually have some stuff here as well. So I'm going to so Helmet follows the convention the KiCad follows, with 3D models, footprints, and symbols, right? And I'm going to do that same thing at a higher level here. So I need to create a new folder. 3D models.
A question. It looks like I think we talked about this a little bit on the stream on Friday, but someone on YouTube is asking BG77 versus BG97.
Yeah, so it's BG95 is the same silicon under the can as BG77. So that's like their part families. The confusing thing is that there's also a BG770 and a BG990. I forget what the 95 equivalent is, but that's actually different silicon under the can with the same footprint. So this is basically like Quicktell's doing the same thing that we're kind of talking about here, where now Quicktell says, oh, we've defined this new footprint, right? And we put stuff under the can, but you might want to deploy different silicon. Then they even abstract out things like AT commands, right? So now silicon from Sony versus silicon from Qualcomm looks the same. They have their own custom commands that they test on this stuff. They have standard AT command sets, things like that. And but if you have that BG77 footprint like we're putting down, you could target either. I think there might be some other capabilities you might want to put in there, but yeah.
Do you get certification with both those parts?
Symbols, footprints, 3D models. I didn't make any of these. Sorry, 1 second. I can't type and talk at the same time, which is great for a live stream. Certification of what?
The FCC certification on the...
Yeah, so they can't sell those modules without this being like certified.
Okay.
So you don't get full certification though. You still need to certify your end product, but not the same like you would be doing like a chip down design, right? And that's ultimately why you have metal cans on there anyways. They're really like keeping stuff under the hood. All right, so let's do this. I got the library now. I'm going to put the step model in here. And then I'm going to put in the footprints here. I have a different library. I'm going to do that. So this is a library that's the Dram.pretty. I could also make a BG77.pretty if I wanted to keep them like completely separate, but I'm going to just use the generic library, I think. All right, so now go back to the design. New. So now I have to add these to the actual project. I'm going to go to manage symbol libraries. Go here. So you see I still have all the ones that imported from the elixir. Many of these are broken. That's a cleanup item need to do later. Input symbols BG77. Okay. So now that symbol will be available for the schematic eventually. Wait. This might be fun. Like KiCad crashing. What does it say? Ah, I see. It's still crunched on the other one. Does it say not found? All right. Let's that's fine. It was trying to find that other library there. So let's go to just remove that one real quick. That might break some symbols here, but that's fine with me. Kind of in that weird interstitial space of like, all right, so now we got to go over to the layout tool, manage footprint libraries, project specific. Actually, oh, sorry, this is already here because it's library. This generic, the project library is already there, so we should be good. All right, so now we're going to add, I'm going to hit A. It's going to load up all the symbol libraries. Errors about what it's not finding. BG77. Mouse over this, hit E. And then you see it's just got the generic footprint there. I'm going to modify this to actually find the footprint that we just put in there. Loading footprints. A different screen. Input freedom. Interesting. Okay, that's not going to work. Why is this not found? Input. Oh, that's why. Change the title. Yeah. Do it. Come on, AI. Where are you?
Yeah.
Fix my stupid mistakes, AI. All right, there we go. All right, so now I'm going to go back to the layout. And hit F8. Lots of errors. That's fine. What I do have is that. Oh, look at that. Not bad. Okay, so this is the footprint here. And what we see is a couple things. One, we see the width of the module is actually approximately the same as the width of the, it's a little bit longer than the 9151. But this is great for like, again, with the module. Now is my video choppy? Man, I feel like
you're fine.
It's just so slow.
It got a little choppy when you were importing there.
Got it. Okay, man. Come on, Lenovo.
Can you move the package back and forth while you move your head back and forth?
Yeah. But ultimately, the width of this. Now, what we also see is there's a keep out area, right? So this is basically saying, I'm not sure why this keep out area is so wide. Let's go into the footprint itself. We'll go edit footprint. It's on the wrong screen. Okay, and then we could go, and so, wow, look at all this other stuff in here. So a lot of this stuff is, these are fields that SnapEDA added, which we can remove. They're all invisible when you actually place them, but they are here for, I guess if I just go E, you see that things like package height, manufacture. Like I if I'm being honest, I'm going to remove all this stuff when it actually goes to the production, because I don't want all this stuff in there. Maybe the SnapEDA link I'll save, but any field that, like, any footprint you bring into the design. So like, for example, so I always do MPN, or sorry, I do MPN1. Yeah. So like, that's how I do, that's how I track the actual manufacturer part number. And then, sometimes I have multiple versions of it, but because this custom field is here, this actually gets applied to all parts in the design. And similarly, if I have, someone else's, so if Mike goes and makes a footprint and hands it to me, and it has this MP field, that also gets applied to every design, everything in the design. So it starts to like if you have messy kind of data on your footprints, especially as you're importing them, it really starts to like spread like a lot. So, and actually this stuff is being imported, I believe, from the symbol, not from the footprint itself. So
is there more fallout to that beyond complexity and file size? Is it going to screw up your manufacturing if you don't take that stuff out?
No, it just is harder to read ultimately, I think. But it really can grow. So if you imagine, like, so say you're like pulling from SnapEDA, Ultra Librarian, you have, a librarian yourself, you have your own designs, whatever. If you don't like start to standardize these fields, it can, like, your spreadsheet basically could have unlimited columns with like only very small things in each one. It's, it gets hard to read ultimately. Okay, so I wanted to mouse over and see what this line is. Yeah, so this is set as a courtyard. Do you guys know what a courtyard is?
It's a layer in KiCad. That's as much as I know.
It's an affordable hotel chain throughout the United States with terrible soap, just the worst soap. Mike and I used to stay at courtyards when we would go to LA, and I've stayed.
I never got is, why do they give you a whole bar of hand soap?
I know.
Why wouldn't they just give you a little pumper so that you use the hand soap you
build
need
it into the wall?
Waste. Yeah.
It's because
I should start traveling with a little thing. Yeah, you travel with like shampoo, and I travel with body wash. I should travel with hand soap as well.
Do you think that they throw it out even if it's not used though?
Yes.
Yeah, I wouldn't be.
Well,
so
they
you
do.
Oh, you mean if it's in the
something with it.
wrapping?
I'm not.
Yeah,
No, if it's in the wrapping, I think they keep it.
I would hope so.
Right, but I opened one at every hotel room I went to because I wanted to use soap when I washed my hands. And
Oh yeah, like the hand soap. Yeah.
Yeah.
yeah. But I think they do something with them that's not necessarily landfill.
Yeah, they do get recycled. Yeah, I've seen a documentary about that.
The yesterday on Strava you get like these little notifications if like you have a they have like different badges basically. It's like you're the local legend if you like do the same route the most number of times in the last 90 days, or you have like course records. And apparently not a lot of people run in where we were staying in LA for SuperCon because that was like the only course record I ever had was on some of those like hills up there.
So like
And
you're
I
on the
got in-
street in LA? Are you crazy?
Well, I guess we weren't even really. I don't know if that's still even considered LA where we were, but
Well, it was the sprawl, but yeah, we were up in
LA County for sure.
yeah,
It wasn't even Pasadena anymore. Where was it? It was
it was outside of
northeast
Pasadena.
Yeah.
But anyway, I got a notification yesterday that someone beat the course record, and I was like, oh, I have to fly all the way back out there just for.
Just
Yeah,
got
so you
24
gotta go to
randomly.
SuperCon.
Yeah, exactly.
Okay, so I was correct. This is the courtyard here. So ultimately, this is this is about placement, I think, and I think we would be okay if like the castellated edges are here, but I would not put any components here because also like the size of like the placement and stuff like that. So it is a wider courtyard than I'd expect. I guess we could go to the data sheet, like being totally basic. No, and see what the data sheet says as well. I will do that probably off camera. But what this tells me is that we are, yep.
Well, this is looking okay because you can have that, I don't know what you call it, like a duck's bill, like this
antenna.
the click headers, like some are longer. So like it's not a problem to put it outside of the header, right? And make your board twice as long.
You're saying like this?
Yeah.
Well, okay. So that's another point I wanted to bring up here. So that I had a change of heart on this side of things. So like we use this as the click header is kind of just a arbitrary size limiter, right? In this case, what I plan to do is actually switch these back to surface mount. And actually, let's just draw an ad hoc. We actually don't have any board outline here. So if we render this, it'll just take a calculation of all the components and say, oh yeah, so this is the size of the board now, which is not that useful. So instead, let's go to layers. We're going to go to edge cuts, and we're going to make our grid real big. And I'm just going to draw an arbitrary border here. And this is for the board, mind you, not the module. And what that does is basically now it redraws this and it says, oh, okay, well, whatever's within the edge cuts, that's what the board actually is now, right? So now we've basically defined a board edge. One thing I'd like to do,
the board and not the module. What do you mean by that?
So good question. We're going to redraw it. So I just wanted to draw it here to show what that looks like. But ultimately, this is what I'd expect kind of the, so say we're going to make the Dram module, but then we're going to make like a microbus Dram breakout, right? That's kind of like the first thing that we would make. So we're going to have two board files here. One is going to be the thing that has microbus headers on it. It'll probably have USB to serial. So it'll have a USB plug, USB to serial chip on it, and probably some power handling. And that's about it, right? So like super simplified version and mounting holes as well, of course, because I'm not a psychopath. And then ultimately that's what on the, when we were talking about the Dram the first time, I said, oh, well, the module is now going to live kind of within this envelope. So let's do that. Let's draw that too. Just as like an ad hoc thing. All right. So now we're going to say user eco 1. This is just like a generic layer here. So now the module would have looked something like this. Oh, if I draw it. Oh yeah. KiCad gets me every time. Click and don't hold it. Click
Yeah.
and release. Okay, so now the
I like
module
that.
would have looked more like this, right? And we can fill the shape, right? And ultimately, can I move this down? I know what I can do. We can middle click on the color, double click or middle click for color change. I thought I did. Where are you at, color change?
Isn't it behind?
Yeah, it might be out behind it. Let's go full screen. Oh, here we go, preferences. Oh, this is a KiCad 8 thing that I'm not used to. This is actually a theme. So it's using theming that I'm used to, like being able to like fast and loose with all my stuff here. So
you want to change your colors, but the theme says no.
No.
This is a theme.
This is the default. So I'd have to create a custom theme. Do I want to do that?
A Dram theme. I think you do.
All right. Getting all the important stuff out of the way, right?
Yeah. We're just going to polish a little bit longer, and then we'll do electronics in like 5 more episodes.
Yeah. Just come back at some point in the future, and we'll definitely have. So I was saying Eco 1. God, there's so many layers now, too. Jeez. What you could kind of see here is that there's different ones that have different. What I really wanted to do was just change
opacity.
The opacity. Yeah, transparency. All right, let's do user 1 here. Did I select the right one? There you go. User 1. And let's change the alpha to 50%. Okay, here we go. And then hit OK. And then we're on a new theme now. Hit save. I'm going to change this.
Ooh, yeah. Oh, I thought that was it.
That was not it. We got to change this to user 1. Now we should see it go 50% opacity. Boom. Okay, so this as like a kind of a module outline here. This is kind of what I was thinking at first, but in reality, I'm not sure if this is going to show up on the design here. Yeah, it doesn't show up on the 3D model, which is fine. In reality, what I'd like to do is I want to switch these back to be surface mount, and I'm not going to put it in between. I just don't think. So this is actually the width of a microbus click header. I don't think realistically, without making like some super long module here, it's going to make sense. So instead, I'd like to actually go to the extents of this. So more like grab the rectangle, go more like this.
Okay, so if you make them surface mount, then they're only on one side, and the other side, your components can span. Yeah. Okay.
So now I'm going to flip this, right? We need room for things like the like a UFL connector. So I would probably want to do. I'm surprised they didn't come through. Actually, did they come through? They didn't come through. All right, we'll have to get the UFL connectors too. But ultimately, I like UFL connector 1 here for like LTE, this one for GPS, that sort of thing. Like making sure I get proper routing. But then in a similar manner now, we have this. I know this is all kind of stacked on top of one another, but this would also work for the same kind of thing, right? So now being able to kind of do a replace in the same spot, doing this sort of thing here, if that makes sense. So now it would be on the edge of this thing. This would be a castellated edge. Underneath the board, these are surface mount, right? Instead of through hole. And then it's kind of changing the game a little bit. I do realize that, but I just think from a realistic perspective, we need to be able to handle that. The thing that might not work, at least in how I have it drawn now, is we need to put in some mounting holes as well. And I don't know if these are test points.
So I'm coming in and out here of doing other things, but the reason that you change these from through hole to surface mount and increase the kind of like module size here was so that you could swap in the BG77 for the 9161.
Yeah, just generally making a more kind of, I don't want to say modular, but like just like, so basically treating the Dram module that we're making here, treating that as a more standard that we're going to use on future designs. So thinking about putting that, so like basically if we just as a test here, right? So we're talking about, I guess we need to make up some names here. So guys, what should we call the Dram microbus? How about the micro Dram? So the micro Dram board basically has a microbus click header on it, and then it has the Dram module on the bottom side, and it has maybe the Dram version has the 9150 and the ESP32C3 on it. That's what we've been talking about. The same module outline would then also go into Sloshy McWashy, and we could use the 9151 and the ESP32C3, or we could flip the script and say, now the ESP32C3 is the main thing, and we're going to use the BG77 with it. Right? That's kind of the idea there. Whether or not that's going to land and take here is TBD, but we're going to try it.
and so like it's less about the fact that like we might want to like put the BG77 on here, and more about that like we're going to have like an ecosystem sort of like connectors and things like that, and shields or whatever you want to say, and we want the same form factor so that when we switch in the BG77, the board will be the same size and that sort of thing.
Yeah, the board is the same size, and literally, like some of this is kind of scar tissue from 2022, really just my whole career. But like, if you if you
let it all out,
if you design in a BG77, right, for example, and you design all your stuff around it, and then BG77 is just not available, right? It just happens that like you can't buy it, trade restrictions come down, something happens, you are just hosed. Like your whole product is a redesign cycle. So like it's always that trade-off of like complexity and the complexity that modularity and like this abstraction introduces, and the kind of the availability and the ability to design stuff later. As a little bit of just reference point for myself, like I used to work in like sustaining engineering, right? So basically designing stuff out after it's been end of life or whatever, and at that point, like you're doing a board spin, and you need to make it act the exact same. Form, fit, and function has to be the exact same as the old version, and there's a ton of work around that. And it's not that a module would solve all that stuff; it would solve one thing, right? It would be two things actually. It would fix form and fit, right? And then it's still up to you to change function, right? The function you still need to make, if you're switching out the BG77 for the NRF51, NR9151 in like AT mode, right? You still have to make sure it works exactly the same. But once it's into that firmware and then also ultimately the software realm, it's not easy, but it's easier. And like that's a thing that firmware is much better at than physical metal layers, right? I mean, like, so
cool.
Where to go from here? So now the hard part is, what are the extents of this other stuff? I think the other thing one thing we figured out in this stream is this does fit in terms of width. That's a good start. I think other to-do items, you know what? Let's put them on in here. So to-do items. We put this on we could put it on user. Yeah, let's leave it on eco one. Okay. To-do items. We need to figure out other components that must be on the Dram module. We need to determine the minimum feature set of GPIOs on the castellated edges. And that's something I thought I was going to do before this stream, but it turns out I was working on a blog post that people saw at the beginning of the stream. And we need to determine whether we should go chip down on something like the C3. And that's really a size thing, right? So should we go smaller on something like a C3, higher requirements rather on a FCC style testing later on? Not not unheard of though, right? So like doing 2.4 gigahertz testing with a chip down design, it happens quite a bit. It would be fine, I think, for this test use case, but basically be kind of unfolding the module that's there, doing a little bit more work when it goes to production, if and when, right? So, but I think because the form factor, so like if we think there's no way we'd ever want to do the testing and things like that, then you should just go with the module, right? That's just the decision you should make up front, and then ultimately the module grows to fit that as well. Okay, we need to finalize the form factor or the footprint. See how this looks on the screen. Great. Oh, you gotta be kidding me. Did that just disappear? Oh my God. Can someone play back the tape? Oh my God. Is anybody watching right now? Can you scroll back and put it in the chat? What the hell just happened? Oh my God. Come on, KiCad. There's still no text wrapping either, which is kind of frustrating. Mike, any help?
You want me to go back and watch the video? I can do that.
No. Well, actually, maybe we should. I mean, that might be the easiest thing to do.
I missed what we lost here. What was
The
it?
world.
The world is yours. I can do it. I'll do it on here. My extremely slow video. This is gonna be like
if I did it on my phone and I could use the like text select from an image option.
Oh, like try to OCR it.
Yeah, like all Android phones can do it. You just have to do it from the context menu. But then
this is gonna be like a Spaceballs.
Are you like Chris? Are you about to stream yourself watching the slightly delayed video of yourself streaming?
That would be sure you nice. Got it, Dan.
Yeah, please do.
This is like I said, it's like Spaceballs.
That these 7 people are here for.
Okay, I got it.
I got it here. All right, here we go. Super meta. Figure out the other components that must be on the Dram module. Text so nice, we wrote it twice.
Man, you cannot watch this live stream on a phone.
Oh, too small?
Yeah, because I thought I'd be able to grab it out of the OCR, but
yeah. I think some of this is limited by the size of the screen too. Like the like this is look at that face. Look at these handsome dudes. Determine the minimum feature set of GPIOs for castellated edges. I should probably do this in a text document, huh? Determine whether we want to chip down the alternative comms part.
I mean, I'm with you. I think doing it all in KiCad is the way to manage a project, right?
Sure. I just meant for not losing your work, though.
Well.
All right, I'm going to place it and then I'll edit it again. Click. All right. There we go.
Maybe you clicked and dragged when you originally created it?
I probably did. I can go back through and actually hear myself swearing here. Did I swear? Finalize the, what did I say? I don't know what I was. Wait, am I now watching myself streaming myself? Guys, I'm inceptioning myself right now. Oh my God, I actually am. Everything's on rewind.
It reminds me of that simulation inside.
This might be a a ridiculous question, but couldn't we also just think about what we need to do?
Nah, come on, Dan. What are you?
I don't mean to criticize your methods here, but
I had already done the thinking, and now the thinking's done. You know what? I should do another layer. I should watch us watching again. I don't remember what the last point was. It just says finalize the. I don't know what it was. Finalize the
then
something.
it must not have been mission critical, and you can delete it.
Finalize the blank. There you go. All right. We've hit an hour, and I have about a half hour before training. I'm going to give myself 15 more minutes to waste everyone's time. First off, everyone that is watching, thank you for coming. A little quieter in the chat today. It's okay, though. I should also start not naming this wiring up the Dram board because I have not done any wiring yet. We're still very much in the figure out the wire outside piece. The problem is you have to make art and like name the thing before you actually stream the thing. I should just do just call it Wednesday hardware stream, huh? All right. So other things I'd like to pull back in. We were having some discussions about this is another thing that actually brought this up was did I get rid of it? Oh, I might have gotten rid of it. The ATEX 608B, which is like a secure element. And one of the things that came up, like, well, why did that go in the Elixir in the first place? And the thought around that was always like, well, even though we have the 9160 on board or now the 9150 on board, which has secure, what do they call it? Like trusted firmware storage area, which is much more highly integrated. You can put certs in there too. We have a bunch of content about certs. You won't always have that. And then, so if you wanted to, again, like if you wanted to abstract and say, okay, now we want to work in ESP-IDF, or we want to work in FreeRTOS, just kind of generically, you might still want to have that processing, but you might not have the hardware on board to do that sort of thing. And something like the ATEX 608B or other certificate storage and secure elements could help to serve that purpose. Not without quite a bit of work still, but yeah.
So does the HSM act the same way as the secure area in the 91? Like, do you write your certificate into the secure module?
The HSM, in the secure element, there is like 16 storage slots. And I believe your private key always stays on the chip. It does not ever get exposed off the chip. So what you're doing is you're basically like generating your public key because the private key is kind of encapsulated in there. I think if you want to generate a new private key, it has like a random number generator and like the elliptical whatever. And that ultimately is what allows you to create a new one. But it never comes off, right? The only thing that ever comes off is like untrusted. It's like challenges and stuff like that. I'm way out of my depth. Way out of my depth. Anyone from Microchip watching? You can tell us how it works. Yeah. Okay. So two things that I think are necessary in this stack up here then. So now we have this here. I think we need to be able to figure out, can we fit the other stuff within this courtyard now as well, right? So this is already showing that the courtyard is too close here. Another thing that came to mind with product I was holding in my hand yesterday that I had only seen on paper. It's just like it had a 9160 on it, but it was so small, and I'd been like looking at this close up of it, and it's so hard to like visualize this. So another thing that I will normally do at this stage of a design is like take the dimensions. Actually, we can see what it is. So I mouse over, hit the space bar. You see the DXTY down here. This actually goes to 0 as you hit the space bar, and then you can see the far edge here. So this is a 24 by 34 millimeter footprint currently. So that's roughly 1 inch wide by like 1 1/4 inch long. But even saying that, it doesn't quite do it justice. You need to print it out. You need to print it out on a piece of paper and hold it in your hand and be like, Oh, okay. I get it now. Like that is super critical. And I think that also is important for when I think about where we might stick this thing in the future, like what it would look like. So that's also an important thing to think about.
I mean, that's a good advice for validating all the footprints for your devices too, right? Like you print it out, you look at it, maybe you caliper it, and you go, yes.
Yeah. So like one thing I could do here is I have, if I can open it. I have a elixir board here. So I could just use that as a reference point, right? So here is the elixir. So what we're talking about right now is basically this is the width of the module, and then it would be like this high. So still like pretty small. I mean, like that's still, the measure you're watching on camera. So like that's not as visceral, right? Like I said, it's really, really hard to do. Otherwise, you really need to like print it out. It doesn't have to be printed. You could also just like measure it and but like holding it in your hand is so crucial, because the number of times that I've like been like, oh, this thing is like so big, and then it's like I order it from like a PCB service, and I get it back. I'm like, what? Why did I do this? I'm not gonna be able to probe this thing. It's just like it's a terrible idea. Look at this. Fearless Leader has been watching. Generate new certs in the secure element. Thank you, Jonathan.
Yeah, very nice.
Yes, exactly. Yeah, and that is the crypto auth lib, I believe, from Microchip that talks to it. And then I think when you're then presenting yourself to the server, ultimately it's like the private key is generated and stored in the secure element, but then it'll pump out the public key like you would present to, like any device would present a public key. It's like it's not the keys to the kingdom. It's just it's like a derivative thing. Guys, is it showing how little I know about security? The way to have a secure element is you put a lock on your case. That's how you do it. You encapsulate it in epoxy, in resin. All right. Okay, so I think other parts we want to have on the board. So I think, and remember, you can't go on the backside of this board either. So I think maybe we want to have a MFF2 like eSIM on here. I think that's, again, like a lot of the newer parts like the 9151, you can do a SIM, an iSIM, we talked about that in the last stream. You can do a SIM directly on the module itself. I think increasingly that will be possible. I do not think you should depend on that though, because that is a recipe for disaster. Like you're basically like, oh, now I can't use a part that doesn't have the iSIM capability, or I found this great new MVNO that has great pricing, but they only have physical SIMs. It's like, okay, well, you're screwed. Another thing we could do is we could actually run, so like talking about GPIOs as well. We could run the SIM GPIOs, or it's basically an I2C style thing talking to an off-board SIM. So we could move that off the module as well, but then that gets a little bit harder for like thinking about like, so like if we were gonna manufacture the Dram module, I think it would want to be like, you have a certificate already stored on the secure element, you have a SIM already soldered down, you have the firmware pre-programmed onto the module and or sub processor, right? And then you just solder the damn thing down and it's good to go, right? It's just like literally like you could put it onto a breakout board, you could put it onto your product, that sort of thing. It's kind of the thought that's in my head at least. And then I could ship another one to Mike when he's like, Chris, this one was not soldered down properly. I'd be like, oh yeah, here's a new one. How I do my designs. Maximum swappability for when I've messed something up and send it to Mike. All right, so oops. Right click, select, filter, do not include outline layers. The thing that this would not, this is all pretty arbitrary currently, but this one would not fit because we would not have room for the all important mounting holes. So let's put some mounting holes in here. So I usually do this on the design here. Again, this is still a mess. Okay, so put a mounting hole down, edit it. Mounting holes have kind of special dispensation in KiCad that they actually don't get populated. They don't go through to the BOM and stuff like that. There's usually filtering for that sort of thing. All right, let's see if we can fit an M3. And I'll make 4.
Why M3?
It is my favorite type of mechanical screw. You know, everybody's got a favorite.
Gotta
right?
have a favorite. Yeah.
Gotta have a favorite. You know, we've run into problems with like things. I think it's a realistic size. Like M2 is just completely unusable unless you're like doing it, you know, microelectronic type of things. I think M3 presents a nice like realistic balance of like, you know, you can use a Phillips head. You don't need like special torques or, you know, hex or anything like that. I think you really can operate pretty easily. And it also kind of puts it back into that realm of like, hold it in my hand sort of thing. Now, granted, I'm talking about, now this is going on the, what do we call it? The micro Dram? God,
but micro bus doesn't have mounting holes.
That's right. This is what the microbus would go on. The microbus click would go onto a board, the micro Dram. Probably shouldn't call it that, to be honest. But it's, again, I'm just trying to define kind of limits here, right? We're operating from a space of like, we don't know what we need here, right?
Oh man, those are giant.
I know exactly, right? This is not that big. So like, I can actually show you on this board here, right? These are M3 holes right here. So this top one.
Oh yeah, those are pretty big.
But like, it's realistic, right? I mean, this is like a realistic size of a thing.
Hold that up again, Chris.
Oh, sorry. Thanks. Yeah. So this right here, see that's
hole? You're right though. That is to the realm of regular fastener size.
Yeah, exactly. Yeah, it's not. And so this is really this would be going on and the board outline that we've been talking about. It is flexible, right? It could be, but it's all just about like setting kind of realistic expectations here, right? So like, I probably would move this guy down. In theory, we could also make, we can make this baseboard a little bit bigger as well. But like ultimately, it's just like, what do we want it to look like? There are no mistakes, guys. Happy trees. Happy trees.
Okay, so I think I'm not on the same page as you here. So
okay, so tell me.
You're actually designing two different things right now.
I am.
So the board outline is like a host board that has the click headers on it, and the white half opacity outline is the actual module that will have castellated edges.
That's right. And and the problem here is that I'm not operating from any like need, right? This is all arbitrary, right? I mean, this is all like, seriously, it's all arbitrary. Even so one of the things I was also thinking about is that future versions of the Elixir would also use this module, right? So like we could talk about like, so like if you can go back to my camera again, Mike.
Yeah.
Right. So we're basically talking about this and this being combined into one. So it's like this, and the element is over here, I think. Yeah. Maybe this. No, it's this one. So like all of those getting shoved down on one module. Now, granted, also this SIP is going to be smaller, right? That's the new. So like this is basically the size of the new one, the part not covered by my finger. And so you could kind of see and potentially even dropping the antenna here as well, right? So it's really just like metal can, 80% of this metal can, UFL connectors, passives, secure element, and then I had also talked about maybe putting this MFF2 on here, right? That's the eSIM. And then the thing we haven't talked about is like, do we want an external memory, right? That's probably a question for Mike. Do you think we need?
Yes.
Yeah.
Yeah.
Always.
You at least need a footprint for it.
Okay. All right. I mean, yeah. I mean, like that's the thing. Like, so then you can see where like this is the exercise, right? It's like we need to do all this stuff because if there's a must-have on there, then and like we haven't even talked about the fact that like some of the actual edge will be used for the actual castellated edge itself.
Yeah, just get into the area of like if we want to have firmware updates for multiple chips on this board, we're going to start running out of the ability to do that, I would think.
Okay.
I could be wrong. I don't actually know how much memory the 9160 has, or how much
Well,
flash
but
it
also
has.
like so for example, like the 52840. So say now we're using the same form factor, right? And we have a BG77 on there and a 52840. Marco, in the reference design he released a couple of weeks ago with the thread-based thing. So say we wanted like thread as the main processor with cellular optional backhaul, right? It's like, okay, that's a lot. We're already talking about a lot of stuff there. But it would totally be possible on this form factor, the Dram kind of form factor outline. But in that case, he had to implement the external memory in order to do firmware update because the open thread stack is just so big. So like, I think that makes a lot of sense. But then, you know, again, it's just trade-offs of size versus whatever. Okay, so external memory, secure element. And like, I feel like you kind of have to gild the lily a little bit. Like that's what Dave Jones talks about all the time. It's like gilding the lily. You put more than you need, but then you have to be ruthless about what you actually, first off, having a footprint doesn't mean you have to populate it. That's one thing, but it does mean like if you want the footprint on there, you need to like size for it at least. So then like putting all this stuff on there, getting it all kind of like, what's it called? Floor planned. And then like being realistic about like, do we need to rip stuff off of here? And then can it still work?
Your BG77 in there, is that a processor?
That's a offloading. That's a AT modem. It does have a processor, but I don't plan to use it.
Okay, so in that case, does the ESP drive the show?
Yes, that's right.
Okay.
Yep.
But not in. Is that in the case of the 9160 as well, or 9151?
No, in that case, it'd be flipped, right? So like,
okay, got it.
That's the thing. Like, I don't expect the Dram module to have the same routing in these different configurations. I expect different configurations. So it'd be like ESP32C3 primary with BG77 cellular optional backhaul. NRF9151 primary with cellular as the primary comms with Wi-Fi Bluetooth optional backhaul, right? And that's in that case, the C3 is doing kind of both duties. NRF52840 primary, maybe thread, maybe Bluetooth with optional BG77 backhaul, right? So these are like I just defined 3 different potential versions of the Dram module, which I don't plan to do, just to be clear. I don't plan to do that, but we need to plan the space and the outer connections, the castellated edges, or else when we decide to make a new version, it's like, nope, you can't do that. Doesn't fit, doesn't have the GPIO, whatever, right? So it's like, that's where the kind of the minimum subset kind of stuff here. All right, so Visalis asks, what about battery and charger chip? And I'm very curious to see the final Dram. That looks like DRAM. That's why we spelled it Drachm. Battery and charger, I think all power is off chip. That's so like there are some modules that are like that where the power's on chip. I think that introduces a very, very large footprint and not a lot of value ultimately. I think if you say 3.3 volts and we're going to have always handle that. So like if there's something that requires a lower core voltage, then you design that in. So like, for example, BG77 takes 3.3, NRF 9150, or sorry, NRF 9160 takes 3.3. They might have lower IO voltage, but these all, the idea being that you have like, you standardize on input voltage, a current requirement. That's like you make your own spec sheet there, and then you're good to go. Did you kill my screen? Is this you telling me I have to stop, Mike?
No, but we weren't talking about what's on the screen, so I just moved
it's
it around a little bit.
That's fine. Actually, we should stop because I have to go do training in 10 minutes. So, all right. So this has been completely unsatisfying on this sort of things. But first off, thanks for the questions, everyone. Thanks for the input as well. Visalis also mentioned Vasilis. Sorry about that. Vasilis also said click module only has 16 pins, but you actually don't need 16. It has 16 pins, but there's some shared, I think. So some is like 2 of those are ground, 1 is power, 1's 5 volt, that sort of thing. So like in that case, so like this micro Dram, right? This landing board for the Dram module that would have a single click header on it. Microbus click header on it. I wouldn't put 5 volts on the Dram module. I would put that on the micro Dram board. And probably I wouldn't even put like a boost so that it operates off battery or anything like that. Like in the simplest case, it's literally just like, it only works when you have USB plugged in. Like that's ultimately like what I think would be the case there. And similarly, like the simplest version would be like 5 volts in from USB, linear regulator to 3.3, right? That sort of thing. So that's kind of where my head's at on this side of things. And we'll figure that out as we go in the future. All right. Sorry about the lack of definition here. Yep. Any other thoughts, guys? Otherwise, we'll be back probably next Wednesday. I'll probably be hopefully a little better prepared.
Cool. Thanks for doing this, Chris.
All right. Thanks for being here. Appreciate your input. See you next time.
See you, folks.